Good morning, children. Last day we were discussing about the separation of the components of a mixture. We have already learned that mixture means it contains more than one substance mixed in any ratio. So the components, we have to separate the components by different methods. The last class we discussed about the simple techniques like filtration, sieving and winning, etc. Then we discussed about the two methods, evaporation method as well as the separation by the evaporation and centrifugal method. Cream from milk, butter from curd, these can be separated by centrifugal method. Similarly, the dye from ink can be separated by evaporation method. Now we are discussing about the next method, decantation. Decantation means separation of two immiscible liquids. Two immiscible liquids can be separated using an instrument named separating funnel. Example, oil and water. Oil and water. We all know that oil and water, they did not mix each other. If they taken a glass or any instrument, they were in two layers. It is different their densities. These two immiscible liquids can be separated by using an instrument, namely separating funnel. This is the shape of the separating funnel is like this. Here is a stopcock. The immiscible liquids are poured into it. It is taken in this. We all know that water is, there is a separation between this. Here is water and here is oil. If we kept it for some time, they separate oil and water between different densities. Oil comes down the bottom of the separating funnel. The name of this is separating funnel. And oil on the top of another layer. Then we open the stopcock. The water came down first and we can collect in a beaker. When it is came the end, we broke the stopcock. So this kind of separation is made use for separating two immiscible liquids where the densities differ each other. So they are taken in a separating funnel. In the separating funnel, the liquid is the higher density at the bottom and the lower density at the top. Then open the stopcock, they collect it into two different. After collecting water from it, we can replace another beaker. Then we can get the oil. So this type of method is used for two immiscible liquids where there is a difference in their densities. It is also used. This method is also used in the manufacturing of iron. The manufacturing of iron, there is so many impurities in the slag. Before we get the pure iron from its ore, there is two steps. On the impurities on a layer and the pure metal, they are mixed well and taken in a separating funnel. The metal part, which is denser than the slag, So the metal part comes, the bottom part of the separating funnel, and the slag or the impurities on the top. So for separation of iron, in the manufacturing of iron, pure iron is separated from its impurities named slag by this process. Then there is also another the method distillation. Distillation. This process is used when two miscible liquids. Decantation is used for separating two immiscible liquids. Distillation is used for separating two miscible liquids. Two miscible liquids where the boiling point differ. The difference between the boiling point is above 25 degrees centigrade. For example, acetone and water. Acetone and water. It is taken in the picture is given in your textbook. The given solution is taken in a round water flask. And heat. Here, the vapors from there, it is covered with a this is the distillation process. The two miscible liquids, are taken in the round water flask and heated to boil. The thermometer is also connected here. Then what happened? Only one condition. The differ in the two miscible liquids which we are taken are differ in their boiling points above 25 degrees centigrade. Here we take acetone and water. Acetone and water. We know that the boiling point of water is 100 degrees centigrade, and then at the same time the boiling point of acetone is below 70 degrees centigrade. So on heating, which substance vaporizes first? Acetone vaporizes first. It comes to this way, and the vapors of the acetone pass this way, and it is cold water is taken inside. Cold water is taken inside. Then cold water in, cold water out. On passing the vapors of acetone here, it is converted to acetone liquid, and it can be collected in a beaker here. So this process is used for the last class. I already told you that we have to in our mind for separation of which is we have to three points in every process. For the name of the process, distillation. Example, acetone, the substance which is separated by the compound separated by the distillation process is, an example is acetone and water. Then the third main thing can be known is which quality of the substance is used for this purpose. Here we use the boiling point of two miscible liquids which differ in above 25 degrees is separated by these methods. So, name of the method, distillation. Example, acetone and water. Property, The boiling point of acetone and water is differ more than 25 degrees centigrade. So this process can be used for separated by this method, distillation. Then another process comparatively very similar to this is fractional distillation. Fractional distillation. What is the difference between distillation and fractional distillation? Only the picture we have to notice that the main difference is in fractional distillation there is a separate fractionating column is attached here. A separate the two miscible liquids are taken here, the flask. The miscible liquids are taken thus early, we done in the distillation process. Fractional distillation is the liquids are taken in the round water flask and it is heated. On heating, the liquid which has lower boiling point vaporizes first, and here there is a separate fractionating column. A fractionating column is attached to the instrument. Then it passes through the fractionating column. There is some water also. And the vapors, as we see in the distillation, the vapors passes through this tube and it is cold water. Here cold water enters and is cold water outside. On this area, the vapors of the vapors tend to liquid and we can collect it here. So this is the fractional distillation. The difference between distillation, normal distillation and fractional distillation, the instrument is there is in fractional distillation. In fractional distillation, there is a separate fractionating column. So commonly, it is used for where there is a very slight difference between the two liquids taken in the where we use it here. The two immiscible liquids where they are boiling different, their boiling points is very little. That is less than 25 degrees centigrade. We use fractional distillation. Here there is a fractionating column. In fractionating column, this is a simple method seen here. There is separate layers here in fractionation. Different boiling points of the can be collected at different points here. This is not seen here. Then you have to understand the principle of this process. That means where the name of the process is fractional distillation. Example is give an example, the petrochemicals. The separation of the components of petrochemicals. But even petrochemicals, petrochemicals means as we mined from the earth, petrochemicals include all the products. For example, petrol, diesel, the fuel used in planes, aviation oil, kerosene, and grease, etc. are combined in the same below the earth. And they mined and there are the components like petrol, diesel, aviation oil, grease and kerosene can be separated by this process. So a separate fractionating column. their boiling points differ only very little. So each component can be separated by each fractionating column. So this method is used. So you know that know the difference between petrol and petrochemicals. Petrochemical means it's a mixture of all these compounds. Petrochemicals means that includes petrol, diesel, aviation oil. Do you know what is aviation oil? The fuel used in plane. Aviation oil, kerosene, grease, the base, and the gases, petroleum gas. These products are mixed. This is commonly, the common name for this mixture is known as petrochemicals. From the petrochemicals, by fractional distillation, we get petrol, diesel, aviation oil, kerosene, and the top petroleum gas. At the bottom, we get grease. So this process is used for separating the components of petrochemicals. Then you compare these two processes. What are the two processes? Distillation and fractional distillation. Distillation is used for separating the two miscible liquids where their boiling point is, difference in boiling point is above 25 degrees Celsius. At the same time, fractional distillation is used for separation of more than two miscible liquids where their boiling point is very close to each other, and below 20, difference in boiling point is below 25 degrees centigrade. Example, they are separating the components of petrochemicals. Distillation, the different boiling points is above 25 degrees centigrade. Example, acetone and butter. Fractional distillation, only difference in the instrument is a separate fractionating column is attached to it. Then the difference in the boiling points of the miscible liquid is below 25 degrees centigrade. Then fractional distillation is used. Then the other method is chromatography. Chromatography is used, name of the method chromatography. Chromatography is used where more than one solute is dissolved in the same solvent. For example, ink, different colors, different solutes are dissolved in water, dissolved in the same solvent or the same solvent. More than one solutes, more than one colors, different colors are dissolved in one solvent. So the different solutes which are dissolved in the same solvent can be separated by this method, namely chromatography. We can see what is it. Take a filter paper. Take a piece of filter paper. Draw a line here, and a drop of ink is placed just on the line. Then it is placed on a beaker of water. You must be careful. The line will be that we draw a line on the filter paper. The line will be just the top of the surface of water. Then we, after some time, we can see that through the filter paper, the ink, different colors are rises to the filter paper. That depends upon the solubility of the solute in water. The solute means the color part of the ink. In ink, black ink, blue ink or red ink, there are more than one colors dissolved same solvent. So when we dip in it, which color or which solute particle which is more soluble in water first rises to the top of the filter paper. Which is less soluble is on the bottom of the solid. So after certain we can see the different colors on the filter paper. This depends upon the solubility of the solute particles of the ink. This process is known as chromatography. Then the name of the process, chromatography. Example, separate dye, dye, dye means color. Separate dye, different dye from the ink. Which property depends upon it? In ink is a mixture of more than one color particles dissolved in it. If we dip the water, the solubility of the different parts of the color or different colors are different, not the same. So, which solute is more soluble rises highest to the filter paper. At the same time, which solute which is less soluble in water takes some and does not rise to the highest value. The highest one we get the solute, the color we get is more soluble, and the top bottom we get the less soluble. So this process is now used in chromatography. Then you must remember these three things. What are they? Name of the separation method, chromatography, example, different dye or color from the ink. The principle is ink is a mixture of different solutes dissolved in a same solvent. Thus, in chromatography, the solubility of the different solutes are different. Which solute is more soluble? It rises to the highest part. Which solute which is less soluble, not at the bottom of the filter paper. So, this process depends upon the solubility of the solutes in the ink. Then the next process, sublimation. In the previous chapter, we learned about sublimation. But sublimation, on heating, solid substance directly go to the vapor state. Without, it does not undergo the state liquid. Similarly, on cooling, the vapor is directly converted to a solid. That is, example, you also learned that ammonium chloride and camphor and the carbon dioxide on cooling carbon dioxide gas, it is converted to solid carbon dioxide. It is also known as dry ice. For example, sodium chloride and ammonium chloride. Sodium chloride and ammonium chloride on heating. Here we take sodium chloride and ammonium chloride. Ammonium chloride has the property of the sublimation. That means on heating, ammonium chloride it directly converted to vapor state. It can be collected in the top. And same sodium chloride remains here. So separating mixture of ammonium chloride from sodium chloride, this process is used. Sodium chloride does not have the property of sublimation. Sublimation means on heating, the solid substance directly converted to the gaseous state. Similarly, on cooling, the gaseous substance directly converted to the solid state. It does not undergo the stage liquid state. So, this process is used for such a substance which has the property of sublimation. Camphor, ammonium chloride, etc. So, we have to remember the name of the process. Sublimation, example, ammonium chloride, principle, those substances on heating, it will directly convert to solid state to gaseous state. Then the other process, crystallization. copper sulfate. We take some copper sulfate, dissolve with pure water. Copper sulfate is taken and dissolved in pure water. A strong solution of copper sulfate is prepared. Then it is filtered. On filtering, there is a solid impurities must be removed. This copper sulfate is allowed to vaporize it for some time, for 2 or 3 days. It is allowed to vaporize. This copper sulfate taken it is placed for 3 or 4 days. After evaporating, what happened? The water will evaporate and the copper sulfate crystals will be remain there. This is used to purify solid substances. Do you understand what is the process? The name of the process is crystallization. What is the principle used for purifying the solids? The substance which dissolves in water and a concentrated solution of the substance which is to be purified is taken. Then first we filter it. What is use of filtration? To remove any undissolved solid impurities present there. Copper sulfate is dissolving in water. Or dissolving in water, if there are any impurities present here, it can be removed by filtration. It is not dissolved in water. Then the pure copper sulfate is kept left for 3 or 4 days. Then what will happen? Water will evaporate to the atmosphere and pure copper sulfate crystals crystallizes out. So this method is also used for the purifying of solid sodium chloride, copper sulfate, etc. For the purification of some solid substance, this method is also used. So the name of the process is crystallization. There is one more method, magnetic separation. Magnetic separation. What's the method used here? There is a mix with iron powder and sand. Iron powder and sand. Iron powder and sand is mixed there. How we can separate it? Using a bar magnet. When we pass over a bar magnet over this bar magnet attracts the iron particles and the sand left there. So these are the different methods of separating the components of a mixture. Can you recall it? What are the different methods used for the mixture? Itself says that the word itself says that it contains more than one substance. We have learned that there are some simple techniques as well as some special techniques. Simple techniques include can picking, filtration, sieving, winning, etc. Special techniques include what are they? One, evaporation. What is the principle? To separate a volatile liquid, a volatile substance from a non-volatile. One of them evaporates and the other left here. Then there is centrifugal method. It is used for when there is a different densities. The denser how much it's go to bottom and lighter at the top. Butter from curd in our form or cream from milk. This was. Then the other method is distillation. Distillation means to miscible liquids where their boiling point is deeper more than 25 degrees centigrade. Then fractional distillation. For example, there is two miscible liquids where their boiling point, the difference in boiling point is less than 25 degrees centigrade. For example, the components of petrochemicals, Now you are now what is meant by petrochemicals. Petrochemicals means the petrol products, petroleum products. When we mine from the earth, it is a mix of all these products. That's petrochemical. The compounds can be separated by fractional distillation. Then decantation. Decantation means separation using separating funnel. Especially in some named separating funnel. There is no principle. The two immiscible liquids, they are taken separating funnel. There is a stopcock at the bottom. The denser liquid at the bottom, collected at the bottom, and the lighter or lesser denser at the top. Then they can go by opening the stopcock. We can separate the two immiscible liquids. For example, kerosene and water. Then we have the sublimation. Sublimation means the substance which undergo directly solid on heating, directly from solid to gaseous state. For example, then the last chromatography. Chromatography is used to separate the colors, different colors in the ink. In our writing ink or dot penning ink, there is so many colors mixed together. So that the compounds can be separated by the process named chromatography. The principle involved is in chromatography is what? The solubility of the different colors are not the same. Which color is more soluble rises to the top of the filter, which is less soluble, which does not rises to the top. Then the last we come to the magnetic separation, etc. So these are the different methods. So all these methods you have to understand the name of the process, which property of the substance is used for separating that component, and third an example of each process. Then we come to the another session, the separation of the components of air. What are the main components of air? Oxygen. Oxygen 20.9%, argon 0.9%, and nitrogen 78.1%. The main components are oxygen, argon, and nitrogen. Then there is minute quantity of hydrogen, inert gases, except argon are also present in there. Then how we can separate the components of air? Now we all know that if you have a vehicle, if into the tire shop, there is a separate tank for normal air and nitrogen. If we want to fill our tire of the vehicle with nitrogen, we pay more highest amount. Otherwise, the normal air, we get normal price. If you want to fill the tubes of the vehicle, tire of the vehicle with the nitrogen, if you don't see, if you don't look at it, then in the next time when you go to the tire workshop, you can see that in a special tank there is a class nitrogen. If nitrogen is means that nitrogen is there collected from the air. Then how we can collect or separate the components of these three main components of air? That means oxygen, argon, and nitrogen. It depends upon their boiling point. Oxygen minus 183 degrees centigrade, argon minus 186 degrees centigrade, and nitrogen minus 196 degrees Celsius. Then here comes another point, which is the highest and which is the lowest. Then if you have any doubt, first you must write it down. Oxygen minus 183, argon minus 186, nitrogen minus 196 degrees Celsius. First, the atmospheric air is liquefied by increasing the pressure and decreasing the temperature. At high pressure, the air is compressed. Compressed means apply high pressure. Apply high pressure and decreasing the temperature, air can be liquefied. How air can be liquefied? By compressing the air. Compressing means apply high pressure. Then decreasing the temperature. The air present in atmosphere can be converted into liquid state. How? Applying high pressure and decreasing the temperature, air can be changed into the gas. We all know that there is present in around us always the gaseous state. On applying high pressure and decreasing the temperature, the air can be changed into a liquid state. Then from the liquid state, the picture is given on your textbook. For your understanding, you must have a clear idea. The air is collected in the liquid state. The air is collected in the liquid state. Liquid air. Then it is slowly increase the temperature. Now in our tank, air is collected in the liquid state. The liquid air is slowly allowed to warm up. Then first, which gas we get first? Then if you want to which gas we collect first, we must know which has the highest boiling point, oxygen, argon or nitrogen. Then we must have a clear idea about it. On its രേഖീയ സംഖ്യകളിലൊക്കെ പഠിച്ചിട്ടുണ്ട്. This is 0, -1, -2, -3, -4, -100, -150, -180. Then last where -180, -183, -186, -196. Which has the highest boiling point or melting point? Highest oxygen, -183. Lowest -196. Left side decreasing, right side increasing. Then on by slowly warming the air, in our tank air is collected in the liquid state. On slowly warming, what happens? Which gas we get first? Nitrogen. When nitrogen is completed, then we go with which gas? Argon. And last we get oxygen. So the highest is -100, -50, -10, -1, 0. On going right side, pin -1, 0, 1, 2, 3, 10, 100 degree positively. So left side decreasing to the left hand, right side increasing. So this is the process which is used for the collecting the different components of air. How we can collect the different components of air? First, what we do, the gaseous state, air is converted, air is present in the gaseous state. Air is present in the gaseous state at a normal temperature and atmospheric pressure. Then we have to change the air into the liquid form. How we can convert the air into liquid form? By applying high pressure or compressing the air and decreasing the temperature, we get the air, we get the liquid. From the liquid air, we slowly allow to warm up. Which gas we collect at first? Nitrogen. Second, argon. Third, oxygen. Thus, we can separate the components of air present in the atmosphere. First, we liquefy and separate the component. So, today we have to learn these things. The separation of the components of a mixture. Air is I told you before, pure air is a homogeneous mixture. Its components can be separated by this method. So, you have to learn the different techniques for the separation of the components of a mixture. So we can today wind up the lessons. You must write down these techniques, examples, and the property of the component. Which property the component is used for selecting that particular method. So read this passage and understand this. We can see the next class. Okay, thank you.